Imagine walking into a building that consumes more electricity than an entire city. A building so loud with cooling systems that you need hearing protection. And inside it, tens of thousands of processors are working together to answer one simple question. What should ChatGPT say next? Sounds insane, right? But this is the hidden reality of the AI revolution. When most people think about artificial intelligence, they imagine apps like ChatGPT, Gemini, Claude, or Grok. What they don't see is the infrastructure behind them, because every AI response you get is powered by some of the largest and most expensive machines humans have ever built. And the craziest part, the companies building these AI supercomputers are now spending more money than many countries spend on their military. Today, we're going inside the machines powering the AI revolution, from Elon Musk's Colossus to Google's secret TPU pods to the project that could become the largest AI supercomputer in history. And by the end of this video, you'll understand why the future of AI may not be decided by who has the smartest model, but by who controls the most compute. Chapter 1. What is an AI supercomputer? Let's start with the simple question. What actually is an AI supercomputer? It's not one giant computer. It's more like a massive team of computers working together. Imagine trying to move an entire mountain by yourself. Impossible. But if 100,000 people each remove a tiny piece, the mountain eventually disappears. That's exactly how AI training works. When OpenAI trains a model like ChatGPT, it has to process trillions of words. A normal gaming PC would take years to do that. So companies connect thousands or even hundreds of thousands of specialized processors and make them work as one system. These processors are mostly GPUs, graphics processing units. Ironically, the chips originally designed for video games became the perfect tools for AI. Because AI is basically a gigantic math problem, and GPUs are extremely good at doing lots of math at the same time. Think of a CPU as a smart office worker. A GPU is like a stadium full of workers all doing calculations simultaneously. That's why AI companies don't buy a few powerful computers. They build entire factories of GPUs, and these factories have become the most valuable infrastructure on Earth. Chapter 2. Here's the part that shocks me. Every time you type a message into ChatGPT, the model performs an enormous number of calculations before generating a response. Not millions, not billions, potentially trillions of operations. And now imagine millions of people using ChatGPT at the same time. That's why OpenAI partnered with Microsoft. Microsoft didn't just invest money, it built the infrastructure. Massive data centers filled with NVIDIA GPUs connected by ultra-fast networking. These clusters are so large that engineers can't think about individual computers anymore. They think about entire warehouses as a single machine. And this is where the AI race gets weird. Because the hardest part isn't writing the AI model, it's building the infrastructure capable of running it. A brilliant AI model without enough compute is like a Formula One engine with no fuel. And that realization triggered one of the biggest infrastructure races in history. Chapter 3. If AI were a gold rush, NVIDIA would be the company selling the shovels. Nearly every major AI company, OpenAI, Xi, Meta, Amazon, Oracle, and many others, depends heavily on NVIDIA GPUs. The superstar chip became the H100. One H100 costs roughly $25,000 to $40,000 depending on configuration. Now remember that number, because companies aren't buying one. They're buying 10,000, 50,000, or even 100,000 plus of them. That means a single AI cluster can contain billions of dollars worth of chips. Then NVIDIA released the next generation, Blackwell. These chips are designed specifically for giant AI models, and demand became so extreme that companies started competing for GPU allocations months in advance. Imagine calling a supplier and saying, "Hi, I'd like to buy 50,000 GPUs. That's a multi-billion-dollar order. And this is why NVIDIA became one of the most valuable companies in the world. Not because people suddenly wanted better graphics cards, because the entire AI industry realized no GPUs equals no AI. But then Elon Musk decided that buying GPUs wasn't enough. He wanted to build one of the largest AI supercomputers ever created. Chapter 4. In 2024, Xi announced a project called Colossus. And the name was not an exaggeration. The goal was to build an AI cluster with 100,000 NVIDIA H100 GPUs. To understand how absurd that is, if each GPU costs around $30,000, the hardware alone could be worth around $3 billion. And Xi reportedly built it in an incredibly short timeframe compared to typical data center projects. The cluster is located in Memphis. Why? Memphis. Cheap power, available land, and existing infrastructure. But here's the crazy part. 100,000 GPUs generate an enormous amount of heat. You can't cool that with ordinary air conditioning. So companies use advanced liquid cooling systems that circulate coolant through the servers. Think of it less like a computer room, and more like an industrial power plant. Xi is using Colossus to train Grok, the AI integrated with X. Chapter 5. Google's secret weapon. Most people assume every AI company uses NVIDIA. Google is different. For years, Google has been designing its own AI chips called TPUs, tensor processing units. Instead of buying all its chips from NVIDIA, Google builds many of them itself, and it connects them into giant clusters called TPU pods. Google uses these pods to train models like Gemini. Why does this matter? Because owning the chips gives Google more control over cost, performance, and supply. Imagine if every airline had to buy engines from one company. Now imagine one airline designs its own engines. That's Google's advantage. Google doesn't reveal all the details, but its TPU infrastructure is considered one of the largest AI computing systems in the world. And this is where the competition changes. It's no longer just whose AI is smarter. It becomes who has the most chips, who has the cheapest electricity, who can build data centers fastest, who controls the supply chain. And that leads us to the most ambitious AI infrastructure project ever proposed. Chapter 6. The Stargate Project. In 2025, reports emerged about a massive AI infrastructure initiative involving OpenAI, Microsoft, SoftBank, Oracle, and other partners. The project became known as Stargate. The reported scale, potentially hundreds of billions of dollars invested over several years. Not millions, not billions, hundreds of billions. The idea is to build a network of enormous AI data centers capable of supporting future generations of AI models. Why spend that much? Because AI models are getting exponentially larger and more demanding. A model trained in May 2026 require many times more compute than one trained in 2024. And companies believe whoever builds the infrastructure first could dominate the next era of AI. Think about that. We are witnessing a new kind of industrial revolution. In the 1900s, nations competed for oil. In the 2000s, companies competed for internet users. In the 2020s, they're competing for compute. Final chapter: the machine behind the machine. So, after everything we've uncovered, one thing becomes crystal clear. When most people think about artificial intelligence, they picture ChatGPT writing essays, Gemini answering questions, Claude helping developers, or Grok generating real-time responses. But those are only the faces of AI. The real story is happening behind the scenes. Hidden inside massive data centers, thousands of GPUs work together every second, solving trillions of calculations that make modern AI possible. These machines don't have sleek designs or flashy interfaces. Most people will never see them in person, yet they're quietly becoming the foundation of the next technological era. We're witnessing a new kind of global race, not for oil, for gold, but for compute. The countries and companies that build the most powerful AI infrastructure could shape the future of science, healthcare, education, entertainment, cybersecurity, and even the global economy. Just as electricity powered the Industrial Revolution and the Internet transformed the digital age, AI supercomputers are becoming the engine of the intelligence age. But with that power comes responsibility. These systems consume enormous amounts of electricity, require billions of dollars in investment, and raise important questions about sustainability, accessibility, and who controls the future of AI. The next breakthrough may not come from a smarter algorithm. It may come from a faster chip, a larger AI cluster, or an entirely new way of computing that we haven't even imagined yet. One thing is certain: the AI revolution isn't slowing down, it's only getting started. And the most important battles won't always happen in front of our screens. They'll happen inside gigantic buildings filled with millions of processors, connected by miles of high-speed networking, solving problems faster than anything humanity has ever built. The next time you open ChatGPT, generate an AI image, or watch an AI-created video, remember this: behind that one simple prompt lies one of the most powerful machines ever created by human civilization. And that's what truly powers the AI revolution. CTA. If you enjoyed discovering the hidden technology behind artificial intelligence, make sure to subscribe to AI Hustle. Every week, we break down the world's biggest AI breakthroughs, emerging technologies, and the innovations shaping our future in a way that's simple, engaging, and impossible to ignore. If this video changed the way you think about AI,